So thank you so much for having me. This is a real pleasure. Again, I've been a big fan of NASA for as long as I can remember. I really enjoyed my time studying physics at Reed College, and there's a nuclear reactor at Reed College that was fun to kind of play with, and really look forward to speaking to you guys. It was a really great introduction. Thank you so much. Don't really need to talk much more about myself, just to say, I've been a programmer since I was in middle school. It's been almost 18 years where I've been being paid to do programming. And over that time, it's really been interesting to see the shift and evolution of the tools that programmers use to do their work. For me, I've been a web programmer primarily for that whole time, so it's really been interesting to see the web transform and become so important and integral to everyday development, everyday life. And so the tools that are being built today to help web developers do their job are really taking it to the next level. And platform as a service is really an exciting technology that I'm really proud to have had a part in when I started my company about 5 years ago. And the idea was, how can I help developers get their code deployed into cloud environments faster and easier? And that was really what I set out to do, and we signed up over 100,000 developers on the platform, and we deployed hundreds of thousands of applications on it. So it's really awesome to see that kind of traction for any technology, and I'm really excited to tell you more about that entire transition, what platform as a service is, how it fits into what's going on today with technology, and where that might be going in the future. So before I go further into this talk, let me tell you a little bit about the structure of the talk. So we already talked about who I am. I want to start by telling you about what's wrong with the developers creating web applications today. What's their pain point? What's the frustrations? What isn't working? Why is platform as a service such an important technology? And how does it fit into solving those problems? Next, I'd like to talk about how the cloud enables innovation. So what is it about cloud technology that makes that developer's world so much better? And where is cloud technology transforming business and technology scale out? Then I want to talk a little bit about the history of cloud from the perspective of a programmer, because of course cloud means many things to many people. For a lot of people, the cloud means their phone or Dropbox, but specifically for a computer programmer, the cloud is very different. The cloud has many forms for a computer programmer, and so we'll talk about those different forms and those transitions. And finally, spend some time talking about what exactly is PaaS, how to use it, and where things are going. And I'll wrap up kind of with the three things. So if you don't pay attention to anything else I say, don't worry, take a nap. At the end, I'll tell you the three things that you should take away from this presentation, and you can have those notes and be good. So let's start with what's wrong with developers. Now, everything I'm about to say is also covered in my book from O'Reilly, Programming for Platform as a Service, and there's a lot more in depth. So I'm going to try to not go too deep. I'll go deep in a few areas, but I'm trying not to go too deep. If you want more technical details, if you want to know exactly how to do programming in a platform as a service environment, so like the 7 or 8 things that you need to look out for, how to transition old applications into platform as a service. I cover all that technical detail in the Programming for PaaS book, which you can pick up on Amazon or from O'Reilly. And so go ahead and check that out. Let's talk about the developer's problem. If it isn't broke, don't fix it. Well, it is broken. Let's talk about how creating and scaling web applications today is broken. And let's do it through a story. Let me tell you the story about Jason Gendron. Jason is a programmer who came up with this great idea for how to do social tweeting better. And so he had this idea and he built it out in his spare time, and it was a really cool idea. And so, like a lot of people, he started on his own, and he started with a simple kind of setup where he created his own server and he just ran it himself. And that actually worked pretty well. So it grew a little bit. In fact, his website took off, and he had 80,000 signups for it, which was very impressive. So he had to add a little bit of complexity, but his simple system worked pretty well until it broke. And that happens a lot, especially when you're starting to scale a web application, when you start to get 80,000 people trying to access it. And what he found is, as a programmer, he was spending half his time, if not more, trying to fix the servers. So he was doing operations. He was doing system administration. He was trying to set up more servers. So he grew his kind of the complexity of his system. He added an application server. He added multiple application servers. They had to load balance each other, and they started breaking. He had to do separate database servers. But it seemed to him like every time he added some more complicated stuff, again, it would break. And then his users wouldn't be happy. So that system kept happening, and he spent more and more of his time trying to run the application, and it was really a mess. And this is what happens for a lot of web applications. The traditional way of kind of scaling out N-tier web application architectures is difficult, it's time-consuming, and web application developers end up spending a lot of time doing that instead of writing code. They scale up to a point, but they're limited. So there's only so much RAM and CPU per server. Databases are limited by disk size and I/O rates. And the more complex they get, the more they end up breaking. Seems like the more moving parts, the more there is to look after. So it's one of those things that it's really easy to get started, but to grow is not easy. And when you're trying to do anything of importance, when you're building APIs or web applications that are being used or need to stay up and have great uptime, traditional three-tier systems aren't delivering the value anymore. The technology has limits. And one way to say that is that building and scaling web applications in that traditional way is fragile. The more pieces, the more components you're putting together in those systems, the more fragile it gets. If your load balancer breaks, now your entire application is broken. If your database breaks, then the entire application is broken. And it doesn't matter that all of your application servers are still running, your users can't access any part of your application. So it's a very fragile system. One part breaks and the entire thing breaks. So that's the problem that web developers are facing today. That these systems for scaling complex applications are not great, and they're very fragile. So what is it about cloud that enables innovation? What is it that can help people like Jason Gendron not spend their time managing servers, but rather spend their time really doing what they do best, writing code? How can we get developers to focus in on writing code, separate out the concerns of running that code, and make it smarter about how the system runs code? So what does the cloud do? Well, before I go into kind of the technical details, I just wanted to talk a little bit about another passion of mine. I read a book by this man here, and it really changed the way I thought about web application architecture, even though the book had nothing to do with web application architecture. And so I'll pose this question to you. What's the opposite of fragile? And a lot of people, when they think, what's the opposite of fragile, their instant reaction is to say, well, robustness. Well, it's not robustness. In fact, there isn't a word for the opposite of fragile in the dictionary. So Nassim Taleb wrote a book and came up with his own word, and he calls it anti-fragile. What is anti-fragile? His definition for anti-fragile are things that gain from disorder. So resilience isn't the opposite. It's not the diametric polar opposite. It's actually a neutral form of fragility. So some examples, a teacup is a very fragile thing. If you hit it with stressors, it will break apart. It's just like a web application 3-tier architecture. You stress out the load balancer and the entire thing falls apart. A robust system is more neutral. It doesn't care one way or another. So some bars of titanium, for example, you hit that with a hammer, it doesn't do anything. It doesn't make the bars don't break, but they don't get stronger. They're just, happy to be the same. They're robust. Anti-fragile is the exact opposite of fragile. So things that actually gain from disorder. Trees are an example of an anti-fragile thing. They actually grow under stress. Stress to a tree makes it stronger. What do I mean by that? Well, if you guys remember the biodome, the first version of the biodome, the scientists had created this perfect environment where they put all these plants and all these animals to try to create a perfect ecosystem. And so what happened is the first version, the trees grew up and then the trees started falling down within the biodome. And the scientists said to them, what's going wrong? How did this happen? We thought we were building a perfect ecosystem. Why are these trees just falling down? And what had happened is that they hadn't taken into account that the trees actually needed stress. There was no wind in the biodome. And the addition of wind, that stressor on the trees, actually made it so that the trees grew roots deeper. The stress made it stronger. And without those stressors, the trees didn't grow deep roots, and so once they got to a certain size, they just fell over. So things that gain from disorder, things that get better with disorder. What are some of the characteristics of a fragile system? They're sluggish, locked in, monolithic, tightly coupled, heavyweight, complicated, without redundancy. That's the characteristics of a fragile system, and that's what a 3-tier or even N-tier architecture generally, you can describe it that way pretty easily. So if that's a fragile web architecture, what's an anti-fragile web architecture? Its characteristics are defined by agility, interoperability. Can you run it anywhere? Decentralized, loosely coupled, lightweight, simple, with lots of redundancy everywhere. So it's interesting to think about fragile and anti-fragility, especially when you consider something like Netflix. Netflix was one of the early pioneers moving into the cloud and has been well known for having adopted cloud practices. And one of their most interesting cloud practices is called the Chaos Monkey. What the Chaos Monkey does is Netflix intentionally randomly kills its own servers in order to ensure architectural anti-fragility. So the Chaos Monkey doesn't kill test development servers, it actually kills live production servers. So if a developer creates code that is fragile, the Chaos Monkey is going to make that very, very apparent very early on, because that's what its job is. Its job is to seek out fragility and make it obvious. No fragility can hide from the Chaos Monkey, because the Chaos Monkey's job is to break things or try to break things. And what that does is it creates a social contract with the architecture design behind Netflix to ensure anti-fragility. So the Chaos Monkey is like the wind to the trees in the biodome. It's the stressor that makes the Netflix cloud system stronger with stress. Adding stress to the system intentionally in order to make it more robust. So go ahead with your question. Yeah, so that's an excellent question. And let me answer it in just a couple slides, because you actually teed up one of the next slides. So the change is happening from a non-standard do-it-yourself 3-tier architecture into managed platforms to run code for you. And the answer to your question is that these anti-fragile systems are much more complicated. They are much more sophisticated, and an average developer is going to have a lot harder time trying to figure it out for themselves. So the kind of technology that you need to build anti-fragile cloud systems are things like orchestration, which does job scheduling, which kind of abstracts away the infrastructure, and it's pretty interesting stuff, but it's also very heavy. There's a lot of language. It's a new paradigm. However, all of that paradigm is being wrapped up behind the scenes within the context of platform as a service, which means that when you as a developer start using a platform as a service, you actually take advantage of robust anti-fragile architectures that have been built for you. Does that make sense? So the old system was a do-it-yourself 3-tier system. The new system uses things like message buses and orchestration. And instead of sending a request into a kind of pipeline where the browser sends a request and it's kind of linear throughout the lifecycle, back to kind of the old do-it-yourself. The request goes into the web server, goes to the application, to the database, returns from the database, and all the way back to the browser. That's a very linear way. The new system is based on a message bus messaging architecture that is much more anti-fragile, much more robust. It has much more redundancy in it, and it's decentralized. But it's also a lot harder to run. The thing is, platform as a service runs it for you. And as a developer, if you start using a platform as a service, and I'll go into different options of what kind of platforms as a service you can use, but what you could take advantage of are modern technology infrastructures without having to figure out how to run them yourself. So before I go into kind of the details of what does it look like to actually use a platform as a service for a developer, because it's actually a lot easier than you might think if you've never used a platform as a service. Let's talk about a brief history of cloud for programmers from the programmer's perspective. So in the beginning, there were data centers. When I started programming, there was no platform as a service, no infrastructure as a service. If you wanted to do it, you had to be like Jason Gendron. You had to set up your own servers. You had to manage your own Apache. You had to put your own load balancers in. I would tune MySQL well into the night. I'd set up MySQL slaves and replication, and it was, I'd have to pay for my servers up front. And so it was really a bunch of patchwork. And then in the 2000s, Amazon came up with this idea of putting an API in front of data centers. And for the first time, instead of sending a request in for a server and it could take 2 weeks, now you could take 2 minutes. And you didn't have to talk to anyone, and you could launch a new server anytime, 24/7, any day of the year. This was a paradigm shift that the world really didn't understand for years. It really has, even today, is trying to be understood by a lot of large enterprises. So it's been 10 years since this concept has been around, and is still being kind of consumed and understood how transformative this is. Build hourly instead of paying up front, scaling up and down. There are a lot of pros, but there's also some cons to infrastructure as a service. Now, one of the cons is that a lot of people think that because you're billed hourly, it's actually cheaper to do infrastructure as a service in a public cloud environment. That's not actually true if you're going to build out significant large-scale systems. Just like renting a house might make sense depending on your time frame. Buying a house, if you're thinking you're going to hold your house for 40 years, you might end up paying off your house. Whereas if you're renting a house for 40 years, you never do. And so it all depends on how long you're thinking of being in that infrastructure, and how much infrastructure you think you're going to be using. So it may be cheaper, but it might be more expensive. So that's one thing to consider with infrastructure as a service. You still have to manage and run your own code. So if you have your application, you're still having to set up those 3-tier architectures on infrastructure as a service. You just can do it without having to send in orders. And this kind of concept of infrastructure as a service is pretty well known. Software as a service has also been something that has developed a lot within the programmer tool world. So software as a service, popular things like Salesforce has transformed customer relation management, but it's also transformed the developer's life. Prepackaged programming services for developers, like sending bulk email, accepting credit cards, they let you write less code. So software as a service is also transforming the world significantly for building web applications. 10, 20 years ago, if you needed to accept a credit card, you would have to build a lot of the payment processing code yourself or license some code from somebody else. Now you don't need to license code. You don't need to figure out a lot of that coding stuff. You can use a prepackaged programming service. And there's software as a service for developers for many different platforms. And if you kind of take the concept of infrastructure as a service being on-demand infrastructure and combine it with the concept of software as a service where it's a managed programmer platform, and you combine those concepts together, what you get is platform as a service, where you still get the benefits of infrastructure as a service in the sense that it's instant, on-demand, hourly cost, but you get the benefit of software as a service where you're no longer managing the operating systems yourself. You're no longer setting up 3-tier architectures. All you're responsible for with a platform as a service is sending your code in, and the platform as a service is responsible for taking the code, compiling it, distributing it onto multiple servers, scaling it out, putting a load balancer, managing the database, all of those things that Jason used to have to do himself, the platform as a service does. And Jason was actually a customer of mine at AppFog, and when he moved to AppFog, it changed his life. He instead of spending half his time running servers, he spent all his time writing code. And that let him grow his business even more, and he was very grateful for that, and it's a really great story. And it really, what Platform as a Service does is standardize the best practices, standardize that message bus architecture that is very, very robust, and make it consumable by developers. So, yes. Absolutely. So the concept first of DevOps, if you haven't heard of DevOps, the concept of DevOps is having a developer have a hand in operations. And there's tools around DevOps like Puppet and Chef that have been built so that programmers can programmatically spin up infrastructure and make it, if instead of having to manually configure Apache every time, a programmer could write a short piece of code which would set up Apache in the same way on every server that it ran on. And so it, for the first time, gave developers kind of a familiar way to start managing and configuring operating systems themselves without having to become system administrators. It kind of was a bridge between the developer and the operating system using code. And the DevOps movement is still thriving, and it's, in fact, when you go to deploy a platform as a service, like we did at AppFog, you actually use DevOps tools to deploy these clustered, orchestrated environments. So if I go back to this slide here, these complicated architectures that have a message bus tying everything together, those are not stitched together by a sysadmin going through and setting up an individual database server and adding it to a message bus. It's not manual. The entire system is done declaratively. So up front, an architect or a developer declares the structure of the foundation of the infrastructure and does it in a programmatic way. He writes code, he declares the how all of the systems interact with each other, and then a DevOps system is responsible for taking that declarative piece of information and turning it into a running piece of infrastructure. So DevOps has gone a long way and has really enabled a lot of cloud development, but the next generation from DevOps is a concept called NoOps. And NoOps is really the ultimate version of platform as a service, because in NoOps, you've completely decoupled the building of code from the running of code. So the developer before, what would happen is the code development and the code running were coupled together in a pipeline, so that when a developer wrote code, he would have to either set up the infrastructure and deploy it himself, and then test it and make sure that it ran within the infrastructure, or he'd send it off to the IT department, and their job would be to figure out how to run the code. But it was a linear process it was very linear. So the developer would have to send it to QA. The QA would make sure it runs that before it would go into production. It was very linear, and as we saw with the 3-tier architecture, most linear systems are fragile systems. So they add time, latency, and it can take days, even weeks, just to deploy a single version of an application linearly, because there's so many components along the way, and it's a tightly coupled system. So developers hand it to QA, QA hands it to production. If there's something breaks along the way, the entire thing breaks and the deployment's broken and nothing works. And everything stops until that's been fixed. In the no-ops concept, we have decoupled the writing of code from the deploying of code and abstracted away that linear relationship so that the people running the system are actually focusing on running just the platform as a service. So the DevOps guys, the operations team running a platform as a service, are no longer spending their time trying to figure out how to run a developer's code. They only spend their time running the platform as a service. It's the platform as a service responsibility. It adds a buffer between the operations and the developers so that they can work at the same time. They can work in tandem and in parallel instead of in sequence. So operations can work simultaneously as the developers, which adds agility to the entire deployment process. Deployment of an individual application is no longer done by the ops team. It's done by the platform as a service itself, which is being run and maintained by the operations team. So the concept of no-ops is not that operations disappears. It's that operations is no longer coupled to the development of the application. And so it adds a lot of speed, and that's how a lot of startups these days are able to deploy their code 20 times a day to a production live environment. That would be unthinkable for a lot of large-scale applications in traditional methods because of all of the headaches and linear coupling that's involved. With platform as a service and no-ops, those concerns are decoupled from each other, which adds a lot of agility to the entire deployment process. That's it. Yes. So what is PaaS? Now, I'm not going to go too deep into this, but if you've never seen platform as a service in action, I just wanted to show you this concept. So, for example, before, if an operations team needed to know if they were going to deploy a PHP application, the operations team would need to know how to deploy PHP. They'd need to know the Apache configuration for PHP. They'd need to know everything about PHP in order for the developers to be able to deploy it. With Platform as a Service, Heroku was one of the early innovators in Platform as a Service, and they're still around, still doing great work. Millions of applications have been deployed on Heroku. And in order to deploy an application into a Platform as a Service, it's always very, very easy for the developer. So a developer can come to a Platform as a Service, create a simple PHP application, and in order to deploy it live, all they would need to do is git push. And that would take their code, bundle it together, and the Platform as a Service, you can see this screenshot, it figures out the dependencies, it figures out the mcrypt and Apache versions, PHP versions. It grabs whatever is necessary, bundles it together on behalf of the developer, on behalf of the application, and does everything necessary to put it behind load balancers and deploy it to the platform as a service. This entire process, this git push, takes a few seconds, not minutes, not days, not hours. It takes seconds. And no operations person was involved in the deployment of this application. It was the platform as a service that took everything, bundled it together, figured out how to run it, and is able to scale it. That concept to an individual developer could have saved them weeks of time configuring PHP correctly, making sure it was secured and tuned, making sure that MySQL was available. All of those little tiny things can add up, and then when you get 80,000 users, it all breaks. With Heroku or another platform as a service, it doesn't break. It's easily scalable. Scaling this to 100 instances with load balancer also just takes a few seconds. Not minutes, not days, not hours, seconds. Taking the same concept, and if you wanted, instead of making a Ruby application, you wanted to deploy a Rails application, there's no difference. You git push your Rails application and it notices that it's a Rails application. It grabs all the dependencies, figures out how to deploy a Rails. If you want to experiment building Node applications, you don't need to teach your ops guys how to deploy a Node application. Heroku or any platform as a service knows how to deploy Node applications. So it will grab the dependencies, bundle them together, knows how to scale them. So it takes all of those concepts and all of the best practices, puts them behind a meshed, layered, scalable cloud environment without the developer having to figure out any of the details. It's really a big transformation in terms of figuring out how to manage code in the cloud. Yes. Yes. No. Yeah, so a lot of those, no, it's not proprietary. A lot of those details are very, there's a lot of differences. Not enough time on this phone call to go into them. My book, Programming for PaaS, goes into those details in detail. But in general, I'll give you one of the biggest differences. One of the biggest differences is between public platform as a service and private platform as a service. So with Heroku, the only option you have is to deploy it with Heroku infrastructure managed by Heroku, run by Heroku. So it's very easy to use. You don't have to do anything as a developer, but you don't have the option of doing it anywhere but where Heroku runs. So if for some reason you don't want to do it on Amazon and Heroku doesn't support anything but Amazon, you can't do, you're out of luck. So then if you use a private platform as a service software like OpenShift from Red Hat or Cloud Foundry from the Pivotal guys, then those systems you do have to set up the platform as a service yourself, but you can set it up on your hardware, on-premise or in the cloud. It doesn't matter. Platform as a service doesn't care if it's on dedicated infrastructure or cloud infrastructure. It doesn't know the difference. It doesn't care. And so you have a lot more flexibility in where you run your applications. You have flexibility on how it's architectured. So that's one of the big differences. Public or private platform as a service is one of the biggest differences, depending on how much control you need building your applications. But essentially, they all do the same concept. They all can deploy the similar applications. They all can deploy Java applications. They all can do Go applications. There aren't languages that don't work within platform as a service. So that's one of the biggest differences. So before we go into questions, I just wanted to do a very brief overview of kind of some of the options that developers have for cloud services if you're not familiar with them already. For software as a service, every kind of thing that you do as a developer might be better done by a cloud software as a service. So running databases, ClearDB, Amazon, Heroku, Mongo, these are all software as a services that run your database for you. Obviously, if you have proprietary or very specialized needs for your database, that doesn't make sense. But if you don't just trying to get up and running, you don't need to do it yourself. Mobile, search, logging, email, background tasks, analytics, errors, DNS, security stuff, payments. All of these have software as a service options, and if you're not familiar with them, you should totally check these out. This list is, the slides are on SlideShare, so you can find this presentation and come back to look for that list. For infrastructure as a service providers, there's dozens, but some of the better known ones: Amazon, Google Compute Engine, Microsoft Azure, DigitalOcean, Rackspace, CenturyLink has a cloud offering. For platform as a service, there's Heroku, there's AppFog, Cloud Foundry. AppFog runs Cloud Foundry. So one of the differences between Cloud Foundry and AppFog, Cloud Foundry is the private PaaS and the one that you set up on your own. AppFog is Cloud Foundry but hosted on your behalf. So it's like Heroku, but it uses Cloud Foundry technology. OpenShift by Red Hat, Google App Engine, Microsoft Azure is a platform as a service. So in conclusion, the three things that you need to remember. So if you've fallen asleep by now, it's time to wake up. Three things to remember. Scaling web applications is hard. Three-tier architectures might be fun to set up if you're just getting into them, but they're fragile. Platform as a service does it for you better. So start thinking about what parts of your application life cycles can you outsource to automated platforms. Whether it's running code, running databases, running third-party services, thinking about stitching together multiple services and leveraging automated systems, automated technologies that do the hard, heavy lifting for you. That's the direction that technology is going, and that's the way the stream is flowing. So it's a lot easier to swim downstream and go with the flow. So again, all of these examples and more are in the book. Goes into code, goes into the differences between every different platform as a service out there. Take a look at it, and thank you for your time. Let's go into any questions. Yes, excellent question. Do you want me to talk about it in general, or do you have a specific question? Yes, there There is a discriminator, and the discriminator is how much control you need building your application. So first of all, let me note, every platform as a service out there runs containers for you. You might not even know it, you may not realize it. Whenever you deploy, when you git push an application into a platform as a service, it is actually compiling your app code into a container. All of them do this, and sending those containers into a mesh. So when you're using platform as a service, you're already using containers. But why would you use containers outside of platform as a service? The answer to that is the more complex applications, architectures are not going to fit into a platform as a service. So maybe 80% of web applications are fine within a platform as a service like Heroku or Cloud Foundry, but 20% of them are going to have requirements that do not make sense within the architecture specified by the platform as a service. So this architecture here, with the message bus done for you, the app servers set up behind the scenes, the load balancer pre-picked, this works for 80% of applications, but when you're making more complex applications, for example, if you were a bank and you wanted to make a day trading system, that probably does not make sense within this format. So you would want to use containers to build your own architecture, which, if you need your own load balancer, you can't rely on the platform as a service, Heroku's load balancer. You have very specific requirements. Then you would want to be using containers and creating your own architectures. You can't create your own architecture within a platform as a service. You have to go with whatever the platform as a service has created for you. Is that good? Yes, so security, that's a fantastic question. The other thing that platform as a service does is it puts a lot of security architecture within the framework of the deployment. So a platform as a service has pre-built in a lot of security functionality for you, and containers are part of that security model. Making sure that the underlying container host is secure. All of those things are done when you set up, when the DevOps environment sets up that orchestration environment. So the Cloud Foundry, which is a platform as a service open source project, has a lot of security built into the platform itself, which you can audit by just looking through the Cloud Foundry code and seeing what it's doing to set up your environment. You can tune it. You can make sure that it fits your policy. If you're using something like Heroku, that security is more of a black box. You have to trust that Heroku's doing a good job because they're not showing you the code they're using in order to enforce the security. So, and then if you need the next level of security and you need to have a lot more control over it, you might go into containers directly and skip the platform as a service. And then just one more note about containers is that there are also some platform as a service that are being built from the ground up around things like Docker. So there's container PaaSes instead of kind of application PaaSes. And those are still young. They're not ready for production environments. They're kind of still maturing, but those are kind of a middle ground between the concept of PaaS and the concept of do-it-yourself with containers as well. You can follow along with a lot of this container news if you go to CentrallinkLabs.com. That's it's a system that I run. It's a blog. We talk about container technology, container news. We work on open source container projects. So if you haven't used Docker or containers before, you might look into an open source project that I built called Panamax, and it makes Docker very easy. So it's something you might look into as well. CenturyLinkLabs.com. Yes, that's correct. So when you're using a PaaS, you can push a button within Heroku to provision a ClearDB database. And you don't have to go to ClearDB directly. You can push a button to set up a Mailgun environment within Microsoft Azure. So yes, usually a lot of these third-party SaaSes are provisionable within a platform as a service. Yeah. It is. It depends, I guess, is the answer. If you are a programmer and you're only lightly familiar with things like Apache and MySQL, chances are you're going to have a lot of trouble setting up Cloud Foundry or a private PaaS environment on your own. If you are pretty good at cloud environments, are pretty good at operations, if you have a background in sysadmin work, if you have a background in DevOps, then it's not simple, but it is certainly doable. Thank you so much. Perfect. Thank you.